In this conceptual mission, we will be sending 5 astronauts to Titan, one of the 146 moons of Saturn. One of the biggest problems of landing on Titan is getting there. Titan is about 746 million miles away from Earth, or 1.2 billion kilometers. In order to travel such a distance, me and my partner have designed an interplanetary spacecraft to carry 5 astronauts there. 746 million miles is quite the distance when Cassini traveled this distance in the span of 7 years at 42,168 miles per hour using a gravity system from Earth to Venus to Jupiter. Obviously, this is not acceptable for our astronauts' well-being.
To reduce the time spent traveling, the Kitchi is equipped with nuclear thermal propulsion, or NTP. NTPs work by pumping liquid hydrogen into a reactor core. The heat generated by the nuclear reaction causes the propellant to transform into a gas which is expelled through the nozzle. Though NTPs are extremely powerful, a downside is the need to cryogenically store the liquid hydrogen due to its extremely low boiling point of minus 252.8 Celsius.
To avoid storing large quantities of liquid hydrogen, the Kitchi has 2 ion thrusters running the noble gas xenon. Ion thrusters work by shooting electrons at xenon gas, making them positive. Using a negatively charged grid, the positive ions are accelerated and leave the discharge chamber at speeds of up to 111,847 miles per hour or 60 kilometers a second.
Because xenon gas is inert, it makes it extremely easy to store for long periods of time. Also, ion thrusters are known to be extremely efficient, meaning the ship will have to carry very little xenon gas to get to Titan.
Even with the shorter travel time, there's still many problems with astronauts staying in space for long periods of time. Without the magnetic field of Earth, a hydrogen-rich shielding like polyethylene will be needed in the living area of the ship to combat solar and cosmic radiation. Without the force of gravity pushing on the human body, muscles and bones slowly deteriorate because of the lack of simple movement that we do on Earth, like walking. By rotating the crew quarters, we can mimic the force of gravity, which helps reduce muscle atrophy. We can also enforce mandatory fitness to keep the astronauts strong in space and on Titan.
When reaching Titan, the Kitchi will do an orbital insertion maneuver with its NTP to slow itself down and start orbiting the moon. Titan is one out of 5 other moons near Saturn that has an atmosphere. Its atmosphere mostly comprises of nitrogen, small amounts of methane, and trace amounts of other gases. Looking at this image, we can see how the atmosphere sticks loosely to the moon due to its low amount of gravity, about 14% of Earth's. Making use of the low gravity in Titan's atmosphere, our astronauts will land on the surface using a shuttle with a lifting body design. A lifting body is a type of aircraft or spacecraft that generates lift with the shape of its body rather than traditional wings. This kind of design allows the craft to glide its way to the designated landing spot, saving fuel and slowing the craft down. When nearing the landing spot, the shuttle will perform a VTOL landing, using powerful RCS thrusters to get in position, then performing a short burn, extending its landing gear and making touchdown. Because of Titan's distance from the Sun, the Moon is extremely cold, at around negative 179.6 degrees Celsius. With such a low temperature, our astronaut suits will have to be equipped with heaters and insulated when they travel outside. On Titan, a cycle similar to Earth's water cycle occurs. The lakes of methane and ethane evaporate, forming clouds, and then raining back down. Methane and ethane both have an extremely low boiling point of minus 161 degrees Celsius and minus 89 degrees Celsius. Liquid methane is extremely flammable, so our astronauts will have to clean their suits of it every time they come back from missions. When landing, covers will have to be placed over each rocket and cleaned before takeoff, so an explosion does not happen when the shuttle goes back to the station. While the challenges are great, the rewards of such a mission could transform our understanding of the cosmos and pave the way for future space exploration to Mars, Mercury, Venus, and more.